we're going to troubleshoot our circuit here. And so we're going to use our test points on our terminal strips. And we're going to do the tie down method, which means we're going to have a reference to our neutral being X2, which is in location 5 right here. So now I'm going to compare 1 to 5. And we'll notice that my meter says that I'm getting 133 volts. Again, my transformer's running a little high today, but that's okay. I get 130 volts, and that from 1 to 5 is verifying incoming power. Now, I want to see if my stop button is making a path. I don't know if the circuit is going to work or not, so when I'm troubleshooting, I go systematically through each component. So if I want to make sure that the stop button is making a connection, I'll check at point 2. And if the hot is coming through point 2, which it is, I'm getting 133 volts again, that lets me know that the stop is closed and connected. Now I can break that connection by pressing the stop button, and that's how I can prove that it's working, because by operating the stop button, I should be able to make the hot go away, and we should see the voltage on the meter drop. So I'm holding it in, and it drops down to 28 volts. Will not be a perfect 0 here because we're dealing with ghost voltage, but I did make the 130 go away and drop down to 28. So that's considered a 0 for us, that there's no voltage there while I'm holding the stop button. All right, let's move on. I want to make sure that that start button is in the open condition and the memory contact's in the open condition. So again, I get my 0 voltage, which is about 24 volts in ghost voltage. And my 0 right now is letting me know that the start and the memory contact is open. Okay, so that's our 0 reading from 3 to 5 because the start is open and not connected. Now I'm going to press the start button, and at the same location, I'm also proving then that when I press the start button and the 133, now down to 132 comes through, that this is a live circuit and the motor should be running. One other thing we can do is we can test the neutral, test the overloads, and that's between 4 and 5. And we're going to see that we're getting millivolts, so that's in base units 0.072 millivolts, and that's showing that the overloads are closed. Now, let's go through a couple scenarios here. What if I don't have memory? Maybe I didn't connect the wires or forgot to connect the circuit. What would be the symptoms or conditions that I would experience if I didn't have memory? Well, it would look like this, and we don't need the meter in here, so I'll get the meter out. One of the symptoms would be that it would start, but it wouldn't stay on. Okay, that's one symptom there. Without the coil connected, nothing would start. So when I would press the start button, I get no reaction. And if I lost the overload, I get no reaction. We would have to then use our testing to figure out if I'm not getting any reaction where the problem is.